Hello everyone. Today we are going to see the lesson surface area and volume. In this video we are going to revise all the formulas which are in surface area volume lesson in detail, and I hope this video is very helpful for you because after watching this video all formulas from surface area and volume learned by you. So let's start. So basically surface area and volume consist of 5 figures. Okay. So in this lesson we are going to watch 5 figures. Which of these 5 figures I will show you. The first figure which we are going to watch in this lesson, that is cuboid. And everyone knows that cuboid is in rectangular in format. Suppose that this is our cuboid, or I will just make it very clear. This is our cuboid. And this is our first figure. Okay, this is our first figure, that is cuboid. The next figure is cube, and that is spherical in shape. Okay, if it is not visible, I will just try to show you. Now it is visible clearly? Good. Okay, now it's looking good. So this is our cube. Next figure, figure number second, cube. Figure number third, that is we are going to watch about cylinder. So I have cylinder here also. Our cylinder, I will just select another type. Okay, this is my cylinder. Okay, number 3. Number 4, we are watching about the cone. We will watch about the cone. So in number 4, I just put cone. And there is no particular shape for the cone, so we have to draw that cone. So I will just take a triangle and plus the arc. So this is my triangle, and I just put an arc here. Now it look like a cone. Number 4 is cone. On number 5 there is a sphere. So there is only circle we want. Number 5 is sphere. Now see, these are the main 5 figures, but this pair we can just cut it between, so it will give us the another figure also, and that is known as hemisphere or halves of the sphere, or we can say semi-sphere also, but generally we are using the name hemisphere. So it forms another figure, that is hemisphere. Okay, so now there are total 6 figures in front of us. Let me just draw the 6th one also. So 6th one I can draw with my tab. Okay, so this is hemisphere. Okay, so today we are going to discuss one by one all the figures and their formulas. Okay, now if you just learn all these 6 figures formulas, then your 50 or we can say 80% of work about this lesson is completed. Okay, so one by one we will just discuss all the formulas. So first of all we will discuss about cuboid. First of all, what you have to remember, that there are 6 figures. Okay, basically 5 figure, but this 5 figures pair is consist of another one also, that is hemisphere. So the 6 figures are cuboid, cube, cylinder, cone, sphere and hemisphere. Just remember in this sequence only. Okay, now actually sequence doesn't matter, but if you just remember in the sequence, you can easily remember all the formulas. So the first one we will watch about that is cuboid. So first I am going to write here cuboid. Number 1, cuboid. Now if you just observe this cuboid, you can easily see that, or let me just take this cuboid below. See, this is my cuboid. Or I will just take this cuboid in the next page. Okay, this is my cuboid. So now see carefully, this cuboid, if you observe carefully, the first side is in rectangular shape. Okay, so we know that for rectangle, the area of a rectangle, if this is a rectangle, then area of rectangle is nothing but L into B, which is L into B, length into breadth. Correct? I hope everyone knows this area of rectangle. Remember my words, that is, there are 3 things. One is perimeter, another one is area, and third one is volume. Perimeter means sum of all sides. And it consists of unit. Only unit. Okay, there is no multiplication of unit. And area is nothing but the area enclosed by these figures. Means area occupied by this figure. Surface area occupied by this figure. So here surface area covered by figure, or we can say closed figure, and the unit is 2 times, means unit square. Okay, and volume. For the volume is the total, means we can say area occupied by this figure, okay, including, it's called volume. It's called volume. So area in, it's not a, actually this is a solid figure. Volume, see, if you just observe the room, any room, then the total area inside the room, okay, it's known as volume. It's known as volume. So volume is nothing but the area inside the solid figure, or we can say closed figure. Solid figure or three-dimensional figure. Three-dimensional figure. Why I said three-dimensional? Because it consists three dimensions, okay, on x-axis, y-axis and z-axis. So unit is also 3 times, that is unit cube. Okay, so this is the basic concept. So for rectangle, we all know that area of rectangle is length into breadth. So I can say that here it is length and it is breadth. But see, this is a solid figure, so we cannot say this is a breadth. This is a height, because we want here 3 dimension, and our third dimension is nothing but height. So second dimension is breadth, so I can say that this is a breadth. Okay, so length, breadth and height. So if you just observe the property of a rectangle, for the rectangle, opposite sides are equal. So this is length, so this is also length. This is breadth, so this is also breadth. So same for this. If this is a length, so this side is also length. This side is also length. We cannot say it's a side, it's an edge, because it's a solid figure. So this edge is also length. It is also L, correct? So there are 4 L's. And for B, see, this is breadth, so this is also breadth. Okay, same for this one and this one. This both are B, breadth. Okay, now height. So this is height, so we can say this is also height, this one is also height, and this one is also height. I hope you understand this. Okay, now I just remove this. Now, so we have to just see, there are 3 formulas we have to just look here. The first one is total surface area of cuboid. Total surface area of cuboid. We can also say that it's TSA of cuboid. TSA of cuboid. So TSA of cuboid, if you just observe that total surface area, there are, see, this is front face, okay, one, this is front face, then I will just highlight this. See, this one is front face and the back face, both are equal, so we can say these are 2, so we can write here length of these 2 rectangles, L into H, L into H. So we can write here twice L into H, 2 L into H. Now this sides here B into H, and this is also B into H, so plus 2 B into H. Why I just add 2? Because we have to add the area. So this is my first and this is my second area, but plus this is my first and this is my second area, plus third one is top, this one length into breadth, and this one bottom length into breadth. So I can write 2LB. So taking 2 as a common, so I get here 2 in bracket LB plus BH plus HL. LB, I just write here LB, BH plus HL. Don't worry about the sequence. So this is the final formula. That is 2 in bracket LB plus BH plus HL. Why I just write LB? I will just tell you for the in next formula. So in the next formula, we are going to see the lateral surface area. Lateral surface area of cuboid. So lateral surface area of cuboid is nothing but the LSA of cuboid. LSA means what? We have to just exclude this top and this bottom. Only we have to consider these 4 sides. This front one, the back one, and this side one, and this side one. So if you just consider these 4 sides, so top and bottom we have to exclude. So in the top you can see L and B are the variables, and the bottom also L and B. So we have to just exclude this LB. That's why I just write it in front. So here I can write the formula 2 in bracket, just exclude this LB, only write BH plus HL. So this is our simple formula for the lateral surface area, that is LSA of cuboid is equals to BH plus HL. And the third one about the cuboid, the third and the last formula for the cuboid, that is volume of cuboid. Now volume of cuboid, just remember one thing, that for the volume it depends on the 3 variables. The first variable is length. The second variable is the breadth, and the third variable is the height. So it depends on these 3 variables, because we can extend this cuboid in this direction. We can extend this cuboid in this direction. We can extend this cuboid in this direction, and we can also extend this cuboid in this direction. So this 3 direction depends the size of this cuboid. The size of the cuboid depends on these 3 dimensions, 3 variables. So we have the volume of a cuboid is simple, that is LBH. L into B into H. And I already told you that for the area, the unit is unit square. And how it is unit square? Just see, there are 2 variables, LH, BH are in multiplication. The units are also in multiplication. So if there is a length is 2 centimeter, consider, and height is also 4 centimeter. So 4 2s are 8. Also centimeter into centimeter becomes centimeter square. So here it is centimeter square, centimeter square, centimeter square. So we just take it as a common. So that's why here 2 variable, and that is unit square. Here also 2 variables are in multiplication. But here in the volume, 3 variables are in multiplication. So centimeter into centimeter into centimeter gives us unit cube. Centimeter you can take any one, that is you can also take kilometer, meter, depends on the question. So unit is unit square, and here unit is unit cube. Now the second figure we are going to watch is cube. That is this cube. So let's just take this cube on our next page. Okay, I just take this cube here. Now see the cube. For cube, again there are 3 formula. One is total surface area. So I am not writing here total again and again. I just use TSA for the total surface area. So first one is TSA, total surface area of cube. If you want, you can also use TSA for the TSA is the abbreviation for total surface area, which includes, now everyone knows that this is a square and the area of the square is nothing but side square because all sides are equal. So if I just say that this one is A, this one is A, so this one is also A. Okay, means all are A here. So A, all are A. So we can say that in a very clear manner, that is, for total surface area, we have to just add the areas of all the faces. So the first face, this face, first one, first face area is A square. And how many such a faces are? First face, then back one, this one, second, then side one, this one, third one, this is fourth one, top is fifth one, and the bottom is sixth one. So there are 6 faces. So can I write here 6a square? Yes, obviously I can write here 6a square. So total surface area of cube is 6a square. A very simple formula for cube. Whereas for the cuboid, we just take 2lb plus bh plus hl. 2 in bracket lb plus bh plus hl. Now, LSA. LSA of cube. LSA of cube is nothing but the lateral surface area, top and bottom excluded. So just exclude top and bottom, and we will just talk about the lateral surface area here. So for lateral surface area, you can see area of the square is side square, means A square. And how many lateral surface area, surfaces are here? So first one is front one, second one is back one, third one is side, and fourth one is this side. So there are 4 side square. And number 3, that is volume. Sorry. Now see volume. If we just talk about the volume of cuboid, so it is LBH because it depends on the 3 variables. And if I just talk about this cube, then we all know that it is also depend on the 3 values, but this 3 value is same, that is A, this A, height one, and this one A. It means I can extend this cube on this direction, and also on this direction. So it is nothing but A cube. So volume of cube is equals to A into A into A, that is A into A into A, which is also equals to A cube. And the units are very clear. For area, it is unit square, and for volume, it's unit cube. Understood this 2 figure? Well, at last we will revise it, don't worry. So now we are just going for the next figure, and our next figure is, let me check, our next figure is here, cylinder. So let's take the cylinder on our explanation page. So I just paste cylinder over here. Now you have to just understand the cylinder very clearly. I will explain the cylinder. Now see, if I just cut this cylinder into some parts, so I can see, or you can also see that there is a circle on the top, this one, this circular in shape. There is a same circle is in the bottom. Correct? and in between there is a rectangular in the shape. There is a rectangle. So see that I just cut this cylinder into three parts. First one is circle on the top, circle on the bottom, and the rectangle in the this curved one. So why we are saying this is curved? Because see, this is very simple. If there is a side, suppose if I just talk about rectangle, or if I just talk about the square or cuboid and cube, if there is a side, then we just talk about lateral surface area. And if there is a no side, see in this cylinder there is a no side, it is curved in nature, so we can say it's a CSA. Like the perimeter, if there is a side, we just talk about the perimeter of the square, rectangle, parallelogram, anything which has a side. But for the circle we use circumference. It's not a perimeter, it's a circumference we are using, but both are the similar. So lateral is also known as curved, but for lateral is used for the sides and curved is used for the curved, means circular in nature, and perimeter is used for the sides and the circumference is used for the circular. Okay, understand this point? Now see this cylinder, if I just cut it into a three parts, I got here first one is circle, second one is rectangle, third one is circle. Now we are going to watch one by one all the formula of this cylinder. The first one is total, or I just write here, I just write formula over here. Number one, TSA of cylinder. Now observe that total surface of cylinder, it consists first circle, so area of circle is pi r square. The second circle, that is pi r square again, so plus pi r square. And the third one is nothing but the rectangle, that is, now observe that this particular rectangle, in this rectangle, we are just talk about this rectangle. If I just talk about this rectangle, it consists of this length and this is breadth. This is length and this is breadth. This is length and this is breadth. So if this is a length, then we can just consider this length as a 2 pi r. Why just consider this length as a 2 pi r? Because this length, I just give the name AB, this length AB is completely cover up the circumference of this circle. And we know that this circumference of the circle is 2 pi r, correct? So circumference of this circle is nothing but 2 pi r. So can I say this length as a 2 pi r? Yes, obviously we can say this length as a 2 pi r, because this AB, that is length of this rectangle, is cover up this circumference of this circle. And this breadth is nothing but the height of this cylinder. So instead of B, can I write here H? Obviously we can write here H, because this is breadth and breadth is a variable. So we can, instead of writing breadth, we are writing height, that is also a variable. So in short, the area of this rectangle becomes, instead of L into B, it becomes, instead of L I just write 2 pi r, and instead of this B, I just write H, so it becomes 2 pi r H. So can I write instead of LB here 2 pi r H? Yes, obviously I can write here 2 pi r h. So we know that here radius is same for this circle also, and this rectangular length also. So can I take pi r as a common? So if I just take pi r as a common, but before taking pi r as a common, I can just add this pi r square because the variables are same. So this will be a 2 pi r square plus 2 pi r h. So now just take 2 pi, now just take here 2 pi and 1 r as a common. So if I just take this as a common, I get here 2 pi r in bracket r plus h. Correct? 2 pi r in bracket r plus h. And this is nothing but the total surface area of the cylinder. Understood? Now, just a second point, means second formula, that is CSA. We are not using LSA. Here it is, we are using CSA because there is no side. There is a curve, so we use curve. CSA of cylinder. So CSA of a cylinder, that is curved surface area of the cylinder, is this rectangle, and this rectangle is nothing but L into B. Instead of L, we are using 2 pi r. Instead of B, we are using H. So the curved surface area of the cylinder is 2 pi r H. Isn't it a simple one? It's really very simple. Now the third one of the cylinder, that is volume of cylinder. Volume of cylinder. Now volume of cylinder, if you just observe the volume of cylinder is depend on the circle, area of the circle. If you just increase the area of the circle, so it means we have to increase this radius. Correct? So area of circle, if you have to increase, we have to increase pi r square. We have to increase pi r square. Correct? And the height, if we just increase this pi r square, the length is automatically increased. Correct? And if we just increase the height, then also the volume, is the area enclosed within this cylinder is increasing. So it depends on this variable, that is pi r square and this h. So volume of cylinder is nothing but pi r square, which is depend on the circle, and h, which is depend on the height of the cylinder. So pi r square h, this is the volume of the cylinder. And see, there are three variables in multiplication, r square and h. These are three variables. So the unit is very simple. Unit is unit cube for the volume. Unit cube. And here in the both one, it is unit square. Okay, unit square. Understood about the cylinder? So TSA of a cylinder 2 pi r in bracket r plus h, CSA of a cylinder 2 pi r h, and volume of cylinder pi r square h. Now let's talk about the another figure, that is cone. Let's take this figure on our explanation page. So here now see this cone. Now if you just observe this cone, or in short, if you just cut this cone, you will get here two circles. First circle is the base one, this circle, okay, and the second circle is this one. Now if you just ask me that how we will get the circle for this particular part, this first part, so I will explain how we will get. Suppose I just cut this circle, this cone, then it is obviously seen that the base is a circular in shape, and if the base is in circular in shape, this base is in circular shape, that is clear for everyone. Now if I just talk about this particular this triangle, it's a triangle, but this triangle is formed by cutting the circle. See, if you just observe the hat of the joker, you just observe the hat of the joker, you should observe that this is not a complete circle. This is your small triangle, and if this is your small triangle, this is your base, okay, and this is your R. But instead of R, I can say it's a L. It's a L. Now this is your B1. So if I just talk about this particular area of this triangle, so it is 1 upon 2 into B1 base into height. Height is nothing but L, because it's a very small. So the infinite triangle. So we can say that here 1 by 2 as a common, and L is also common, and this B1 plus B2 plus B3 up to so on. So it will include 1 by 2, this L, and this B1, B2, B3 is nothing but the circumference of the circle. Correct? This is nothing but the circumference of the circle, that is 2 pi R. So here it is 2 pi R. So in short, curved surface area. Okay, in short, this particular area, and this is nothing but this curved surface area of the cone, and this is nothing but a 1 upon 2 pi R L. But here, just remember this 2 and 2 get cancelled. So this 1 upon 2 is also get cancelled. This 2 get cancelled. So here only pi R L. So pi R L. So this is the area of this curved surface area. Why we just calculate first of all CSA of cone? Because for TSA of a cone, we have to add all this, correct? So now we are writing properly. So now we are writing one by one. Means number 1, TSA of cone. TSA of cone, that is curved surface area plus area of the circle, base circle, area of base circle. So CSA of curved surface area of cone, curved surface area of cone is nothing but pi R L. And how this pi R came, you understand? This we just take as a L, that is slant height, and this is our base. Base is nothing but sum of all base B1, B2, B3, that is 2 pi R, and this is the radius. So pi R L plus area of the base circle, that is again pi R square. Now taking pi R as a common, so pi R in bracket L plus R. Now the question arises in your mind, that is this L and R are same, so why you just take it differently, R and L? Yes, this R and L are same, but I just cutted this part and just remove from the circle. Okay, when I just cutted this part and remove from the circle, the small part is subtracted from the area of the circle. That's why we just take L and R differently. Okay, if you still have any problem about this R and L, you just comment me, I will just give the answer. Now the total surface area of a cone is very simple, that is pi R in bracket R plus L. So number 2 is our CSA of cone, and CSA of cone is nothing but pi R L, that we already calculated. And the final one, that is volume of cone. Now remember this thing, the volume of cone, this cone is the part of cylinder. If you observe carefully, Because we can simply put this cone inside the cylinder and it occupy 1/3 part of the cylinder. So the volume of cone is same as the cylinder, that is 1/3 part of the cylinder, that is 1/3 pi r square h. Pi r square h. Because if you just observe carefully, if I just draw the cylinder here and then I just draw the cone with the same height and same base radius, you just see that this is the height, this is also h, this is also h, this is r. Okay. So there is a 1/3 part occupied, 1/3 part of the cylinder occupied by the cone. So this is the 1/3 of pi r square h. Understood? So this is for cone. Now the last figure is remaining, that is sphere. So let's talk about the sphere. So sphere, I just talk about the sphere here only. Now sphere. Sphere is very simple. Now there is no curved surface area, there is no total surface area, only surface area of a sphere. Number one is surface area of sphere. And that is very simple. Area of a circle is pi r square and this is a sphere, so it's 4 pi r square. Okay. And how it comes, no need to just worry about it. It's a 4 pi r square as it is. Don't think over it. Because see, if you just cut it the circle and just make a 4 part, then you will get here 4 circles with the same radius and the area of that 4 circles is equals to the area of the sphere. So if you just cut it the circle in and just join it and find out the area of these 4 circles, so this area of this 4 circle is nothing but the area of the sphere. That's why it's 4 pi r square. If you don't understand, don't worry, just remember this formula. So second and the last one is volume of sphere. Volume of sphere. So volume of sphere is nothing but 4/3 pi r cube. Remember, there is a cube because in the unit is a unit cube always. So here unit is unit cube for the volume, and for the area it's the unit square. Okay. Now the last one is a hemisphere. Understand these two formula. Now the last one is hemisphere. So again I just take hemisphere below it. So for hemisphere, see, the hemisphere consists of here, the hemisphere consists of curved surface area also, total surface area also, and volume also. So I just write here first of all curved surface area. CSA of hemisphere is equals to CSA of a hemisphere, that is curved surface area of hemisphere, plus base circle, base area. Now CSA of hemisphere, curved surface area of hemisphere, is nothing but half of this area of surface area of sphere, that is 2 pi r square, plus base area, base is also circle, so that is pi r square. So it will become 3 pi r square. Correct. Now the second one is, sorry, this is a total surface area. This is not a curved surface area. This is a total surface area. First we just talk about the total surface area of a hemisphere. Now we just talk about the surface area. Curved surface area of hemisphere. Now curved surface area of hemisphere means this curved part, that is 2 pi r square, half of the total surface area. It's not half of the total surface area of hemisphere, it's the half of the total surface area of sphere. And the volume of the sphere, volume of sphere or we can say, sorry, it's not sphere, it's a hemisphere. Volume of hemisphere is half of this volume of sphere, that is 4 by 3 pi r square, again half, so 2 by 3 pi r cube. So unit are very clear, that is here it is unit cube and here it is unit square. Okay, just revise this quick revision, start the quick revision. So first of all, we just talk about the surface area volume, about the 5 figures. Basically it's the 5, but we just converted into 6 figures. First one is cuboid, second is cube, third one is cylinder, fourth one is cone, fifth one is sphere, and sixth one is hemisphere. So first we just talk about the cuboid. In the cuboid, the TSA of a cuboid is 2 in bracket LB plus BH plus HN. Unit is unit square. Then LSA of a cuboid is 2 in bracket BH plus HN. Unit is unit square. Volume of a cuboid is equals to LBH, that is unit cube. Now cube, TSA of a cube is 6a square, LSA of a cube is 4a square, and volume of a cube is a cube, and the unit for this area is unit square and the unit for this volume is unit cube. Now the next figure we just talk about, it's a cylinder, and cylinder, so TSA of a cylinder is 2 pi r in bracket r plus h, and CSA of a cylinder is 2 pi r h, and the volume of the cylinder is pi r square h. Now here it is unit cube, here it is unit square. Just remember this point. Now we just talk about the another figure, that is cone, and cone is slightly different from the other figures. So just see the DSA of a cone is pi r in bracket L plus r, and that is unit square. Unit square. Here also unit square. And for the volume it's a unit cube. So TSA of a cone is pi r in bracket L plus r, CSA of a cone is pi r L, and volume of a cone is 1 by 3 pi r square h, and unit is unit cube for the volume. And the last figure, that is a sphere. For the sphere, surface area of the sphere is 4 pi r square and volume of a sphere is 4 by 3 pi r cube. For a hemisphere, TSA of a hemisphere is 3 pi r square and the CSA of the hemisphere is 2 pi r square, whereas the volume of the hemisphere is 2 by 3 pi r cube, and unit is unit square for the area and the unit is a unit cube for the volume. I hope you understand this complete surface area volume lecture. Thank you for watching this, student. Thank you so much, everyone.